One of the most important fields where ordinal regression is widely used is healthcare. Let's take a closer look at how it helps medical professionals analyze patient satisfaction, treatment outcomes, and quality of care. One of the most important real-world applications of ordinal regression is in healthcare. Medical professionals and researchers often work with ranked data, where patients report their experiences, symptoms, or treatment outcomes on an ordinal scale. These rankings are not just numbers, they represent critical information that helps doctors and healthcare providers make decisions. But to extract meaningful insights, we need the right statistical tools, and ordinal regression plays a key role. Let's consider a case study on patient satisfaction in hospitals. A healthcare organization conducts a survey asking patients to rate their experience on a 5-point scale. Very dissatisfied, dissatisfied, neutral, satisfied, very satisfied. The goal is to determine which factors most strongly influence higher satisfaction scores. The survey also collects information about factors like doctor communication, wait times, hospital cleanliness, and treatment effectiveness. Step 1. Data collection and preparation. The hospital gathers responses from 1,500 patients who recently received care. Each patient provides a satisfaction rating along with feedback on their experience. To prepare the data, the satisfaction ratings are treated as an ordinal variable with a meaningful ranking. Independent variables such as doctor communication, wait times, and cleanliness are formatted correctly. Missing values are addressed to avoid bias in the analysis. Step 2. Applying ordinal regression. The hospital runs an ordinal regression model to analyze which factors most strongly influence patient satisfaction. The model generates coefficients and odds ratios, showing how each factor affects the likelihood of moving to a higher satisfaction level. Doctor communication. A strong positive coefficient suggests that better doctor communication significantly increases the chances of receiving a satisfied or very satisfied rating. Wait times. A negative coefficient indicates that longer wait times decrease the likelihood of patients giving higher satisfaction scores. Hospital cleanliness shows a moderate positive effect, meaning cleaner hospitals lead to better patient experiences. Step 3. Implementing data-driven improvements. Based on the results, the hospital now has clear insights on how to improve patient satisfaction. Some key actions they can take include training doctors and nurses in better patient communication, since this has the strongest impact on satisfaction. Reducing wait times by optimizing hospital workflows and staffing levels. Maintaining high cleanliness standards, which positively influences patient perception. This case study demonstrates how ordinal regression helps hospitals turn patient feedback into actionable insights. Instead of just knowing that some patients are satisfied and others are not, ordinal regression explains why. By identifying the key drivers of satisfaction, healthcare organizations can make evidence-based decisions to improve the quality of care. Now that we have seen a case study in healthcare, let's move on to another industry where ordinal regression plays a major role: market research. Businesses rely on ordinal regression to understand consumer preferences, predict customer satisfaction, and improve their products. Let's explore how companies use this technique to make data-driven decisions. Education is not just about passing or failing, it's about understanding student progress, learning difficulties, and the factors that influence academic success. But evaluating student performance is not always straightforward. Letter grades, exam scores, and course ratings are often ordinal data. They follow a meaningful order, but the gaps between them are not necessarily equal. A jump from a C to a B might not mean the same thing as a jump from a B to an A. This is where ordinal regression becomes a valuable tool for educators. Let's look at a case study on student academic performance. A university wants to understand what factors influence students' final course grades, which are assigned as fail, pass, good, excellent. Instead of just looking at raw test scores, the university collects additional data on study hours, attendance, participation, previous academic records, and access to learning resources. The goal is to determine which factors most strongly predict higher student achievement. Step 1. Data collection and preparation. The university gathers data from 5,000 students across multiple courses and prepares the dataset. Final course grades are treated as the ordinal dependent variable, following a clear ranking from fail to excellent. Independent variables include study time, attendance, participation, prior academic performance, and access to online resources. Missing values are handled to prevent bias in the analysis. Step 2. Running the ordinal regression model. The university applies ordinal regression to analyze the relationships between student behavior and final grades. The model reveals which factors increase or decrease the likelihood of higher academic achievement. Study hours. A strong positive effect, meaning students who dedicate more time to studying have a much higher likelihood of receiving a good or excellent grade. Class attendance. A moderate positive effect, showing that students who attend more lectures perform better, but the impact is not as strong as study time. Prior academic records. A significant predictor. Students who performed well in previous courses are more likely to excel in their current studies. Participation in class discussions. A positive impact, meaning engagement in discussions, correlates with better grades. Access to online learning resources shows some impact, but not as strong as other factors. Step 3. Applying the insights to improve education. Now that the university knows which factors matter most, they can take data-driven steps to improve student outcomes, encouraging more structured study time, possibly through mentorship programs or guided study sessions, increasing attendance incentives such as participation credits or interactive learning activities, enhancing academic support for struggling students by identifying those with weaker prior academic records and providing targeted interventions, promoting classroom engagement, ensuring that students are actively participating rather than passively attending lectures. This case study demonstrates how ordinal regression helps educators go beyond simple grades and uncover the real drivers of student success. By identifying the factors that most strongly influence academic performance, universities can design better learning environments, support struggling students, and improve overall educational outcomes. Market research is all about understanding consumer behavior. Companies spend millions of dollars conducting surveys to determine what customers like, what they dislike, and what influences their buying decisions. But survey data is often ordinal. Responses are ranked but do not have equal spacing. This is where ordinal regression becomes essential for drawing accurate conclusions. In this case study, let's imagine a company launching a new smartphone. They conduct a survey where customers rate their overall satisfaction with the product on a 5-point Likert scale. Very dissatisfied, dissatisfied, neutral, satisfied, very satisfied. The company wants to know what factors drive higher satisfaction ratings so they can improve their product and marketing strategy. The survey also collects data on features like battery life, camera quality, design, and price. Step 1. Data collection and preparation. The company gathers responses from 1,000 participants who purchased and used the smartphone. Each participant provides a satisfaction rating and additional details about their experience with the phone. Before analysis, the company ensures satisfaction ratings are coded as an ordinal variable, maintaining the order of responses. Independent variables like battery life, camera quality, and price are properly scaled to ensure they do not distort the model. Missing values are handled to prevent bias in the results. Step 2. Applying ordinal regression. The company runs an ordinal regression model to determine how different factors influence customer satisfaction. The model outputs coefficients and odds ratios, showing which features have the strongest impact on moving a customer from one satisfaction category to a higher one. Battery life. A strong positive coefficient suggests that longer battery life significantly increases the likelihood of a customer rating the phone as satisfied or very satisfied. Camera quality, also positively associated with satisfaction, but the effect is smaller than battery life. Price. A negative coefficient suggests that higher prices decrease the likelihood of achieving top satisfaction scores, meaning that customers feel the phone is overpriced. Step 3. Business decisions based on the results. Using these insights, the company can now make strategic decisions. Prioritize battery life improvements in the next model since this has the strongest impact on satisfaction. Maintain high camera quality, but recognize that it is not as critical as battery performance. Consider adjusting pricing strategies to make the phone feel like a better value to consumers. Additionally, marketing teams can tailor their messaging. Instead of just promoting the camera, they now know that emphasizing long battery life will likely have the biggest impact on increasing customer satisfaction. This case study highlights how ordinal regression helps businesses go beyond simple averages and uncover hidden patterns in ranked data. Instead of just knowing that some customers are satisfied and others are not, ordinal regression explains why. By identifying the key drivers of satisfaction, companies can make data-driven decisions that lead to better products, smarter pricing, and more effective marketing strategies. Now that we have seen a case study in market research, let's summarize everything we have learned about ordinal regression and its applications across different industries. Now that we have explored the theory, applications, and real-world case studies of ordinal regression, it is time to bring everything together. Let's summarize what we have learned and highlight the key takeaways that will help us apply ordinal regression effectively in real-world scenarios. Ordinal regression is a powerful statistical method used for analyzing ranked categorical data. Unlike linear regression, which assumes numerical values with equal intervals, ordinal regression respects the ordered nature of categories while acknowledging that the distances between them may not be equal. This makes it the best approach for analyzing survey responses, performance ratings, pain scales, and any other situation where data is ranked but not evenly spaced. We started by understanding what makes ordinal data unique and how it differs from nominal and continuous variables. We then explored where ordinal regression is used, from customer satisfaction surveys and healthcare outcomes to education research and business analytics. We walked through the step-by-step process of running an ordinal regression analysis, including data preparation, ensuring ordinal variables are properly coded and missing values are handled, model selection, comparing the proportional odds model to more flexible alternatives when assumptions are violated, result interpretation using coefficients, odds ratios, and p-values to extract meaningful insights. We also explored how to implement ordinal regression in R and Python, showing that both programming languages provide robust tools for building and evaluating ordinal models. Then we looked at the common challenges that can arise in ordinal regression, such as multicollinearity, small sample sizes, and assumption violations. Understanding these limitations allows us to detect and correct potential issues before they lead to inaccurate conclusions. Finally, we explored advanced techniques such as Bayesian ordinal regression, mixed effects models, and evaluation metrics like Cohen's kappa and ordinal AUC, which help improve model accuracy in complex datasets. Through our case studies, we saw how ordinal regression is applied in healthcare to assess patient satisfaction and treatment effectiveness, and in market research to predict customer preferences and improve business strategies. Ordinal regression is not just a theoretical concept. It is a real-world tool that helps businesses, researchers, and policymakers make better data-driven decisions. Whether we are analyzing customer reviews, predicting employee performance, or understanding public opinion, ordinal regression allows us to move beyond basic averages and uncover the true drivers behind ranked outcomes. By mastering ordinal regression, we can transform messy survey data into actionable insights, improve decision-making, and develop more effective strategies in healthcare, education, business, and beyond. This concludes our deep dive into ordinal regression. Now, the question is, how will you apply it in your own work?